Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NEET, GATE, NT exam, PhD exam, SET exam, Tifr, IIT-Jam, Jest and other exams related to physical science. Okay. So this is the third part of this series of CSIR NET Physics June-November 2020 paper solutions. Okay, so I'm solving those PYQs of June-November 2020. Okay, so I'm going to start, and also I would request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay. Okay guys, so I'm going to start now. Question number first. Question number first is 3 infinitely long wire 3 infinitely long wire each carrying equal current are placed in the xy plane along x equal to 0, comma plus d, comma and minus d. Okay, so at this distance these infinitely long wire are placed. Okay, on the xy plane the magnetic field on xy plane the magnetic field xy plane the magnetic field vanishes at number A, x equal to plus minus d by 2. Option B is x equal to plus minus d into 1 plus 1 by root 3. Option C is plus minus d 1 minus 1 upon root 3, 1 minus 1 upon root 3, and option D is x equal to plus minus d upon root 3. Okay, so these are the options, guys. Okay, very good question. Question is 3 infinitely long wire each carrying equal current are placed in xy plane along x equal to 0, x equal to d and x equal to minus d on xy plane. Okay, on the xy plane the magnetic field vanishes at. Okay, we need to find magnetic field where the total magnetic field, the point where total magnetic field because of these 3 wire will be 0. That's what it is asking. What is the magnetic field vanishes at? Okay, So I'll make a figure. Okay. So this is like this. This is XY plane. Okay. And this is the so one the uh, one wire is along this y direction, okay, at x equal to 0, okay, and another wire is this infinite wire, okay, this is at x equal to distance d, okay, this is d distance, and the another one is at x equal to minus d distance, okay, this d distance, so minus d minus d comma 0 and d comma 0, okay, so these are a wire, guys, okay, these are wires, okay, these are infinite wire, guys, okay, infinite wire, 3 wires, and they are placed in x y z x y plane like this, okay, so this is along y axis, guys, because x equal to 0, and this is at d distance, this is minus d distance, okay, so now I will solve it. So guys, we can number it, okay, we can number it like this. This is wire 1, okay, this is wire 2, and this is wire 3, okay, wire 1, wire 2, and wire 3, okay. Now suppose there is a point, this is the point x, guys, here the magnetic field vanishes, means total magnetic field because of these 3 wire is 0, so this is the point x, this is the point which is x distance from there, okay, this is x distance, okay, okay, this is at x distance, okay, from second wire, okay. So now very simple, so because the magnetic field vanishes, it means the total effective magnetic field is going to be 0, so we can write like b1, so we can say this is b1, guys, okay, this magnetic field because of this at this point, because of the one, the magnetic field is for this first wire is b1, and this for b2, and for this b3, okay, so we can write b1 plus b2 equal to b3, right, it balances this, okay, at this point the total effective magnetic field is 0, it means b1 plus b2 equal to b3, okay, that means if that means b1 plus b2 minus b3 equal to 0, okay, plus b3 equal to 0, so this is the condition, guys, okay. So now we'll at this point, suppose this is at x distance, at point is p, okay, at this point the magnetic field is 0, effective magnetic field is total net magnetic field is 0, okay. So now we'll find b1, so from this is equation 1, okay, you can say equation 1, okay, very simple, so this is b1 plus b2 equal to b3, right, so we'll find b1, so we know the magnetic field because of infinitely long wire, right, at any point, that we know, right, if it's infinitely long wire, then magnetic field is b is mu 0 I upon 2 pi d, okay, this you need to note down, mu 0 I upon 2 pi d, because of infinitely long wire at any distance, d is the distance, okay, mu 0 I upon 2 pi d. So we'll use that formula, that's all, simple formula based. So this is going to be mu 0 I is current is same, okay, current is suppose I, okay, because they have each carrying equal current, okay, so I, so this is going to be I mu 0 I upon 2 pi d, this distance, guys, this distance, because of b1, because of first wire, the distance is going to be, this distance is d plus x, okay, this distance is x, okay, this is going to be 2 pi d plus x, okay, 2 pi d plus x, and this is going to be plus mu 0 I upon, because of this wire, this is x distance, okay, so 2 pi x equal to, because of this distance, this one mu 0, this total distance, this distance is d guys, or this distance is x, okay, so means d minus x distance is going to be, so mu 0 I upon 2 pi d minus x, okay, mu 0 will get cancelled, 2 pi will get cancelled, so this is going to be 1 upon d plus x plus 1 upon x equal to 1 upon d minus x. Now very simple, solve it. So this is going to be, this will solve x plus d plus x, okay, upon d plus x into x, okay, and this is going to be 1 upon d minus x, okay. So this will solve it. So this is going to be very simple calculation, d square minus xd plus this one, okay, will multiply it like this, okay, and this is going to be plus 2xd minus 2x square is going to be equal to dx or xd plus x square, okay, we just cross multiply it, okay, x square plus dx, okay. So this will solve it. So this is going to be d square minus xd minus 2x square, right. So this is going to be this xd, and this will get cancelled. So this is going to be d square equal to 3x square. This will go here, right? And so from here, the value of d is going to be okay, value of x, my apology, value of x square is going to be, value of x square is going to be d upon d square upon 3. It means value of x is going to be d upon root 3 plus minus, okay. Okay, so value of x equal to plus minus d by root 3, okay. So this is what are, so on xy plane the magnetic field vanishes at what point? So magnetic field will vanish at x equal to from there, right, at x equal to d by root 3, okay. Very good question, guys, okay. So you should know that the magnetic field due to infinitely long wire is mu 0 I upon 2 pi d, okay. Well guys, this question is done. Next question we are going to solve. Next question is question number 2. Question number 2. This is the following figure. The following figure, the following figure shows the intensity of the interference pattern, interference pattern, in the young double slit, Young's double slit, Young's double slit, Young's double slit experiment, Young's double slit experiment with two slits, with two slits of equal, two slits of equal width, two slits of equal width is observed on a distant screen, on a distant screen, distant screen. Okay, figure is given, I'll show you. If the separation between, if the separation between the slits is doubled, slits is doubled, slits is doubled, and the width of the slit is halved, then the new interference pattern is best represented by okay, so this is the question. Okay, let me just check whether I'm audible or not. This is important. Question number 2. Yeah, I'm audible, so I'll proceed further. Okay, so figure is given. First figure I'll show you, this one. Interference pattern is given. Okay, this is like this. Zero, 1, okay, -1, 1, -1, 2, -2, -3, 3. Okay, this is the one, and this is the interference pattern is given like this. Difficulty in drawing, guys. Okay. like this. Okay, it is not exact, but like this. Okay, this is the interference pattern, right? Okay, this is the interference pattern which is given. Okay, now what we have done is, this is double slit, right? In the following figure shows interference pattern intensity of interference pattern in young double slit experiment with two slits of equal width is observed on a distant screen if the separation between slit is doubled. Okay, so what we have done is, separation between slit is doubled and the width of slit is halved. Okay, then what is the new interference pattern best represented by? So this is the initial this one interference. Okay, now options are given. I'll show you the option. So this is option A. This is 0, this is 1, this is 2, this is 1, this is 2, minus 1, minus 2, this is minus 3, this is 3. Okay, similarly option A, this is option B, this is option C, and this is option D. Okay, 0, 1, 2, 3, 0, sorry, 0, 1, 2, 3. Okay, 0, 1, 2, 3, 0, 1, 2, like this. Okay, and I'll make a diagram. So this is like this. I may not be able to make exact, but this is the one. Okay, we have to understand the concept, guys. That's all. Okay, we have made mistake here. This is 0, guys. So we'll start with 0. Okay, this. Okay, so this is the interference pattern. Okay, so it is not. So this is similar, but it's not looking exactly. But my aim is to understand you the concept. Okay, so figure you can check it that in the 2020 paper, the exact figure. Okay, so here like this. This interference pattern. Okay, and here this is just this one and this one and this one. Okay, and the third one is option D. Option D is, this is 0, 1, minus 1, minus 2, minus 3, 0, my apologies, so this is 1, minus, oh sorry, my apologies, 2, 3. Okay, this pattern is like this. Like separate one. Okay, this one, this, this. Okay, this is the pattern. Okay, this is the one. Okay, this is distance, This is the interference pattern, guys. Okay. So here we'll use the concept. Okay, very simple question. So here we know that we know the young double slit experiment, right? This is young double slit experiment. I have already explained in my optics class, right? So this is like this. Okay, this is the screen. These are slit S1 and S2. Okay, and this is the principal maxima. And at this point, we have to find like intensity, right? This one, right? We know this double slit experiment. Just showing you. Okay, so what we have done is now we have done is, so we have increases the width to slit of equal width, right? Observed. Okay, if separation between the slit is doubled, we have doubled the separation between the slit. Okay, and width of the slit is halved. Okay, so this one. So this is this is distance b between the slit S1 and S2, right? We have doubled it, and this is the width of the slit, right? We have halved it. Okay, then what would be the interference pattern, right? So which graph is going to best to describe the interference pattern, right? So here we know the formula fringe width, right? Fringe width, we know fringe width. Just to make you understand. Okay, so fringe width is, we know the fringe width. Okay, fringe width beta is d lambda upon d, right? This is the formula, guys. I have explained in my lecture. Okay, beta equal to d lambda upon d, right? So now we have increased the slit, the slit separation between the slit. Okay, so we have doubled it. So beta is going to be lambda d upon 2d, right? Just double it, means this is going to be 1 upon 2 of d lambda upon d, right? Half of this, right? So this means as d is increased, as d is increased, okay, increased to 2d, beta becomes half, right? The beta will be half, okay, as d is increased to 2d, right? This separation. Okay, so beta will be half. Okay, the fringe width is half. Okay, and second, this is first case. Second, as the slit width, this is the slit width, guys. Okay, suppose this is the slit width. This is slit width. Now we have half it. Okay, slit width. Okay, so as slit width E, as slit width E is reduced to E by 2. We have reduced to half. Okay, slit width reduced to E by 2. So width of, if we okay, if we half the slit width, in that case what is going to happen? So width of central envelope, okay, width of central envelope will be increased, okay. So first is beta. We have if we double the separation between the width, then the beta is going to be half. Okay, and if the slit width E is reduced to E by 2, if you make slit width is half, then the width of the central envelope is going to be increased. Okay, will be increased. So from here, this graph is the correct one, because you can see the central envelope is the width of this is the actual one, right? After the doubling the separation and halving the width, you can see this the, the width of envelope will increase. Okay, increases and dense, right? So option B is the correct one. Okay, so this will be correct. So it is, see here, it is between -1 to 1, right? So now it is between 2 to 2. Width of the envelope is increased. Okay, if you reduce the if you reduce the width of the slit, then width of then the width of the central envelope will increase. Okay, and this will be dense, right? And dense as well. So this is the correct option. Okay, B. I hope guys you have understood it. Next question we are going to solve. Question number 3. Question number 3. Question number 3 is, it's a good question. Let E, which is function of electric field I am talking about, okay? E, which is the function of x, y, z, and t, equal to E naught cos 2x plus 3y minus omega t. Okay, so this is omega t, where omega is constant, where omega with the electric field of an electromagnetic EM wave, electromagnetic wave traveling in vacuum, which of the following vectors is a valid choice for E naught. Okay, options are I cap minus 3 by 2 J cap. Option B is I cap plus 3 by 2 J cap. Option C is I cap plus 2 by 3 J cap, and option D is I cap minus 2 by 3 J cap. Okay, so this is the question. Very good question, guys. Let E equal to E naught cos 2x plus 3y minus omega t. Okay, where omega is constant, be the electric field of an electromagnetic wave traveling in vacuum. Okay, which of the following vector is valid choice for E naught? So which of the following vector is valid choice for E naught? That's we need to find out. Very simple question, guys. Okay, so I'm going to solve it. So this is okay, so we know from here, since we have been given, I'll try it in next page, since we have been given E, electric field is given of electromagnetic field. Okay, E is given, which is function of x, y, z and t. Okay, e naught cos 2x plus 3y minus omega t, right? So from here we can get the value of k. K we know, right? So here this is k dot r plus omega t. R is we know, right? So k value is, this is 2 I cap or x cap, we can write 2x cap 2x cap. I'll write I would be better. Okay, 2 I cap plus 3y cap. Okay, 3 j cap. Okay, or x cap and y cap we can also write 2 I cap 3 j cap. How? Because we know k dot r equal to this is k dot r equal to 2x plus 3y, right? So k dot r means this one, r we know, right? So 2 I cap plus 3 j cap into, that is dot, r value is x I cap plus y j cap, this we know, right? R is position vector, right? This is in 2D. So if you solve with this dot product, so this value is going to give, this is dot product, this value is going to be 2x plus 3y, right? So k dot r equal to this. So from here k value is 3 I cap plus 2 I cap plus 3 j cap. This is the k vector, guys. Okay, so now we guys, for E naught we need to find out. Okay, so for that we know E dot, my apology, it's a k value we know, right? That is k dot E is going to be, will make k dot E equal to 0. So from here if we do k dot E equal to 0, so from here value of, from here you can find E naught value. So valid choice for E naught is going to be x cap, or we can write like this. Okay, I cap minus 2 by 3 y cap. So we'll just we'll do dot product and we'll get this. The value of choice for E is going to be I cap minus 2 by 3 j cap. Okay, or y cap we can write 2 by 3 j cap. So let's check which option is matching, guys. Option D is matching, I minus 2 by 3 j cap. Okay, it's a j cap, 2 by 3 j cap, I minus 2 by 3 j cap, I cap minus 2 by 3 j cap. Okay, this is the best choice, I cap minus 2 by 3 j cap. Because how we have got it? Well, what we'll do is this one, very simple, k dot E, right? K dot E we need to find. So E naught, k dot E naught, right? K dot E naught. So what we so just we can take this and this, right? And this is going to give this value. I hope you have understood it, guys. Very simple. So E naught, the best choice of for E naught is this, I cap minus 2 by 3 j cap, I cap minus 2 by 3 j cap. Okay, guys, next question. Next question is a very good question, guys. Question number 4. Question number 4 is, okay, so this is, guys, I'll show you, this is E naught, guys. Okay, this is E naught, k dot E naught equal to 0, we'll say. So if you, how we have got this value, because if we do dot product of this, I'll explain this as well. If you do dot product of this with this, because I have written directly, right? So I'm just going to explain. So this one, okay. So if we multiply this k, or if we do dot product with k with this vector, this is going to give 0, okay, 0 vector. So that's why this is the best choice, okay, best choice. So E is the best choice. So E not this one is the best choice, okay. So because we have done dot product one by one, okay, and this dot product is going 0 vector, it means this is the correct choice for this, because we know k dot E not equal to 0, okay. Next question we are going to solve. Next question is, I'll write it. Next question is very good question, guys. It's from vector, okay, vector analysis. Two time dependent two time dependent non-zero vectors, that is q which is function of t, okay, and v which is function of t, which are not initially parallel to each other satisfy vector u cross del v upon del t, very important, okay, minus vector v, this is vector v cross del u upon del t equal to 0, okay, at all time t, okay. If the area of parallelogram parallelogram formed by u, vector u which is function of t, and vector v which is function of t, okay, b is a which is function of t, okay, area, and the unit vector the unit normal vector, okay, the unit normal vector to it, okay, the unit normal vector to a, right, the unit normal vector to it, b n cap which is function of t, then we have been given options. Option A is AT, that is area which is function of t, AT increases linearly with t, okay, linearly with t, but nt is constant. Nt is constant. Okay. Option B is AT increases linearly with T. AT increases linearly with T, but NT rotates about U cross V. Okay, U cross V. Okay, these are function of T, guys. Okay, option C is AT is constant. AT is constant, but N, which is function of T, N rotates. Okay, N rotates about U cross V. Okay, and option D is AT and NT are constant. Okay, very good question. Simple. Two independent time dependent non-zero vectors, okay, which are initially not parallel to each other, satisfy this relation, okay, all the time T. And if the area of parallelogram is formed by U and V is AT, okay, then the unit normal vector and the unit normal vector to it, this area B n cap, the B n cap T, then this is the condition, guys. Okay, n cap. So this is n cap, guys. Okay, this is n cap, not n vector, n cap. N cap. Okay, so now we'll solve it, guys. Very easy question. I'm going to solve it, but very good question. So guys, we know AT vector AT is U cross V, right? U cross V, U is function of U and V are function of T, right? U cross V, this we know, right? Area of parallelogram, right? This is U cross V. Okay, so this is the U cross. This is a vector U vector A, guys. Vector A is going to be that area vector is U cross V. Just okay. So now n cap which is perpendicular to this, right? And this value we know, this is going to be U cross V upon mod of U cross V, right? Because we know any vector n cap equal to any vector upon mod of that vector, right? This one. And now so we'll check, this is the n cap, right? Now we'll check d n cap upon dt. So if we differentiate it, this is going to be, or we can write this is 1 by a into, so this is area vector of this is going to be, area vector is U cross V. Okay, this is area vector. Okay, A upon U cross V into U cross V, right? This we can write because mod of U cross V is the area. Okay, this is the area of parallelogram. Okay, area of parallelogram. So this is 1. Now we'll differentiate with respect to 2. So this is with respect to T. This is going to be 1 upon A will be common, right? The first function U cross dV upon dt plus second function minus, okay, yeah, plus second function, this is going to be V into V cross del u d, this is d, okay, du over dt, right? So we can write dn cap upon dt, this is going to be 1 upon a, okay, this is the area, okay, this is the area, this is the area vector, this is going to be 1 upon a, and this we can write u cross dv upon dt minus this one, this we have done mistake, guys, okay, so this is vector product, guys, so we have to be careful. So second function in differentiation of dv, okay, this is the one. We write this is, now we can write this minus v cross du upon dt, du upon dt, right? Because with the vector property, right? A cross b equal to minus b cross a, right? This is the vector property. Now this value is 0 given in the question. This value is 0, right? So this means dn cap upon dt is going to be 0. This implies vector n cap is constant, right? Vector n cap is constant. So, and we also know that is AT, that is area of parallelogram, right? That is mod p cross u or u cross v, my apologies, u cross v, that is constant, right? Because it's a mod, right? It's constant. So we can see both are constant. N cap is also constant and AT's area is also constant, right? It means which option is matching, guys? Option D. A and T are constant. I hope, guys, you have understood it. Okay, guys. So this is the question. A very good question, guys. Where we just simply solved it. Okay. So we have been given this, right? This one, AB, UV vectors not initially parallel to each other, and the condition is given an area of parallelogram of UV and the unit normal vector to it be, okay. So area we know, right? And area is constant, right? Area vector is not constant, but area is constant, right? So option D is the correct. AT is the area and the unit normal vector are constant. Okay, guys. So I would also request the student who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay guys, thank you so much. Bye now. So today I have take 2 classes. Okay, thank you guys. Bye now.